Right, another hobby I have besides making lathe tools is making knives and making survival tools. And this evening I'd like to show you one of the knives I've made, a couple my family have made, and I want to show you how to make this nice quality engineer's scribe tool or marking gauge, an adjustable tool, which you can make very quickly and easily on the lathe, and it's a great tool to have in the workshop for various other things besides making knives. So the first knife is one that I have made, and I made this out of 01 carbon tool steel. It's a full tang knife where the blade, meaning the blade goes right the way through the handle, is one piece. And this is a copy of the Ramir's survival knife, made to the same dimensions. I've made this one with an olive wood handle with black liners, and it's held together with brass and stainless steel loveless bolts, which I made on the lathe, and a brass lanyard liner. This is a great survival knife. It keeps its edge well and is very easy to sharpen. And I bought the sheath separately, and it had a place for a fire steel at the back, and then I bought a fire steel and made a wooden handle with a brass toggle on the back to keep the knife. And that's, like I say, a great knife to make if you're into making knives. So the next knife is one that my brother made, and this is made from a shortened or cut down British Army machete or gollock. It has a paracord bound handle with an aluminium end, a steel bolster or finger guard. This is a great survival tool. Great for chopping wood with a nice weight. Has nice wide bevels, very sharp, and I'm very pleased that he gave me this knife. And the last knife, or dagger should I say, I'd like to show you this evening is one that my father made. And it's based on a World War II British Army Commando dagger. This is a beautifully ground knife. I don't know how he ground this bevel so accurately. I was told that he took hours to make it. It has a brass bolster or finger guard, a brass end, and the handle is made of holly. Has a lovely finish and some nice knot marks, and the sheath is made of solid wood with a dark wood liner, central liner. The decoration on the sheath is made of cut leather, and the belt loop is made of copper, and it's a beautiful dagger. It's very sharp. There's a bit of a story behind this dagger, because my father sold it to a market trader, a local market trader, without me knowing about it. And I was walking through the market one day and I saw it on the stall for sale, and the market trader sold second-hand fishing equipment as well. So I rushed home quickly and got some fishing tackle and did a deal with him to buy it back. And now I'm going to keep this and hand it down in the family. Like I said, it's a beautiful dagger, beautifully made, and I'm very pleased with it. Now the adjustable marking gauge or scribing tool that I've made out of brass and stainless steel. I had some brass bar which is 38mm in diameter, and some stainless steel discs which were 40mm in diameter and 3mm thick. And the pointed end was made out of an old drill which was sharpened up. And I'll just show you now how I made it on the lathe. The spindle through the centre there is 6mm stainless steel bar. Right, I finished, turned and formed an angle on the back of the brass with this HSS tool here. Has an angle on both sides and a nice radius for in the corner there. And then I've done a fine straight knurl on the diameter with a couple of decorative grooves, centre drilled and pilot drill through. And now I'm going to drill and tap the locking screw hole with my Toolpost drill. Right, I've set my Toolpost drill up ready to do the drilling. I've got the small Jacob's chuck on the end with a small centre drill. I've locked the saddle and it's ready to go. As you know, you can use various different drives to drive this Toolpost drill. You can use an ordinary electric drill, a battery operated drill or a Dremel, but this evening I'm using a different method to drive it. I have the drilling flexi shaft, and that is connected to an extended Jacob's chuck which is held in my Chinese mini lathe chuck. And I'm going to use the Chinese mini lathe with its variable speed to drive the Toolpost drill to do the drilling on the Myford lathe. So that's the centre drill done, and now I'll just change the drill. And I'm drilling it for a 1/4 UNC thread. So the drilling size is about 0.195. And if you leave the saddle locked up, it's all in position and ready to follow the centre drill hole. And that's the core diameter done. So I've put a 1/4 UNC tap in the Jacob's chuck here, and a tap wrench fitted securely to the back of the spindle. And now I loosen off the brass collar on the back of the Toolpost drill so that the spindle can move freely through the housing. And then when you do the threading, the tap will naturally pull the spindle through the housing, and you can finish doing the thread on the component. If you do run out of room on the threading, you can just do a few threads and then take it off and finish it off on the vise, knowing that the first few threads are nice and square in the component. So that's the handle part of the tool basically finished, except for the hole through the centre, which is still undersize, and I'm going to leave it like that for reasons I'll show you later. And for now, for anyone new to lathe work, this is a trick to use when parting off the job. You don't want the brass falling down or flicking off the lathe and damaging the work that you've done already on it. So you use a smaller drill than the hole that's drilled through the centre there, and push that up inside the job, and then do the parting off. And the drill catches the component and stops it falling on the lathe bed and ruining the work that you've already done. Right, to keep the video as short as possible, I've cut out some of the basic machining operations. I've drilled a 1/2 inch diameter bore in the stainless steel disc, put a small chamfer on the back and a larger 45-degree angle on the front, and I've turned a diameter on the front of the brass gauge, and that one fits nicely into that bore, a nice fit, and it protrudes about 1 millimeter from the front face of the stainless steel disc. And that's so that I can swage the brass on the bench anvil into that 45-degree angle, and that will hold the disc nice and squarely on the front and prevent it from coming off. So that's what it looks like at this stage. So the disc's on the front there, and this is my vice anvil that I've shown in another video, and it's basically bash it several times until the brass goes into the angle. And that's the disc swaged onto the front of the brass. The brass has filled the 45-degree angle there, and then I can put it on the lathe again and face off the front, and the brass will look like it's inset in the stainless steel. Then you can turn off the top so that blends in on the diameter, and then it's basically drilled through to suit the 6mm spindle, and that would be the job finished. So that's the marking gauge faced off nice and cleanly. I've faced the brass centerpiece a couple of thou deeper than the face of the stainless steel, so that when I'm using the tool it won't mark that face up. And the spindle goes in there like that, and it's fully adjustable. I had this locking screw in my spare parts, so I used that. If you haven't got one like that, you can just use an ordinary Allen bolt, and you can use it for marking up knife blanks to get the bevels exactly the same on either side. And you can also use it to mark the center of the knife blank on the side, to make it easy when you're grinding or filing the bevels, so that the blade will be dead center. So like I said, it's a great tool for knife making, plus it has other great uses around the workshop for marking out other items.